Now let's find the Nash equilibrium for this game. So if we have one juror only, and this juror is deciding whether, after receiving information or evidence on the defendant, is going to have to decide whether the defendant is guilty or innocent, whether he votes to convict or acquit. So let's suppose that the juror's signal is B, that the defendant is innocent. To find whether the juror prefers conviction or acquittal, we need to find the probability that the juror is guilty given that the probability that the defendant is guilty given that the juror received the signal B. So the probability that the juror is guilty given that the defendant received the probability that the defendant is guilty given that the juror received the signal B is equal to the probability that the juror received the signal B given the defendant is guilty multiplied by the probability that the defendant is guilty divided by the total probability that the defendant receives the signal B, which is the probability that the defendant receives the signal B, whether the juror receives the signal B, whether the defendant is guilty or innocent. So this is the total probability the juror receives signal B. And this is the probability the juror receives signal B given the defendant is guilty. And this is the probability that the defendant is actually guilty. And from the probabilities that we defined earlier, the probability that the defendant receives the signal B given that the juror receives the signal B given that the defendant is guilty is 1 minus P, and the probability that the defendant is guilty, which the juror has beforehand, is pi, and so that's 1 minus P times pi, and the probability that the defendant receives the signal B given that the juror receives the signal B given that the defendant is innocent is Q, and the probability that the defendant is innocent is 1 minus pi. Therefore, acquittal yields an expected payoff at least as high as does conviction if and only if Z is greater than or equal to 1 minus P pi over 1 minus P pi plus Q 1 minus P, 1 minus pi. So remember that Z or Z from earlier. Let me just try and find it. Is the probability of guilt required for the juror to want the defendant to be convicted? So basically, acquittal yields an expected payoff at least as high as conviction if and only if Z is greater than or equal to the probability that the defendant is guilty, given that the juror received a signal that he's actually innocent. Okay. And if the juror's signal is G, not B, then by the same process, conviction yields an expected payoff at least as high as does acquittal if and only if Z is less than or equal to P times pi over P pi plus 1 minus Q 1 minus pi. So we found this using the same process that we used above. So using the probability of guilt given that the signal is G. Therefore, if Z is within this range, then the juror acts optimally according to her signal, acquitting the defendant when the signal is B, and convicting when the signal is G.